Hey everyone, uh, good morning or afternoon, I guess, depending on which time slot I'm going to be allocated in today's class. My name's Raytan, and I'll be doing my green status listing assessment on Reef Manta rays. I want to start off this presentation by rectifying a common misunderstanding that a lot of people might have. Reef manta rays, the species I'm going to be talking about today, used to be classified as part of giant oceanic manta rays. Its status as a separate species was confirmed in 2009. And its genus was also changed in 2017, where it changed from Manta alfredi to Mobula alfredi. And they're considered the second largest species of ray in the world, only surpassed by their cousins, the giant oceanic manta ray. Their size at maturity is estimated to be around 2.5 meters to 4 meters in their wingspan. The age at maturity for males is about 6 years, for females is about 8 years. They're very long lived, estimated at about 30 or so years. They have a very slow gestation period of about 12 months, and regionally they vary in how much they reproduce. It ranges from about 1 to 5 years, and they have a very low annual fecundity rate at about 1 pup per mother a year. 2 pups have been recorded, but it's very rare. In terms of their ecological distribution, they're very widespread. They're widely distributed throughout the Indian and West Pacific Ocean and are mostly found in coastal reefs of continents and oceanic islands, and they frequent shallow waters. They sometimes venture out to temperate seas because they are migratory, and they have a very diverse local and regional population. What does this mean for their global population, though? Well, it's very patchy. Distribution is not uniform and highly fragmented, and because they are migratory in nature, they're influenced by local oceanographic conditions and seasonal productivity. Most records of these animals are collated from dive ecotourism. That being said, regional population numbers and connectivity are poorly studied, and while long-term site fidelity has been recorded in parts of the world such as Indonesia, Mozambique, Maldives, Hawaii, and Australia, their total population size is very difficult to assess. And it's very varied regionally. So it's about 900 in Hawaii and Mozambique per location, 180 to 560 in the Maldives. The meta population of Western Australia is thought to be around 1200 to 1500. 560 of those was recorded in Ningaloo Reef. Despite this, there has been no evidence of recorded interaction between regional populations. Dispersal is thought to be limited due to bathymetry and oceanic circulations, and this means that their subpopulations can become very isolated and genetically bottlenecked. So what does this mean? Estimated global population size, viable population size, we don't know, really. What we do know is that in the last 75 years, or 3 generations of mantas, historical population is seeing a decreasing trend, up to as much as 80% in some areas, but it is estimated to be around 30 or so percent globally. What's threatening them? What's dwindling their numbers? They are long lived, slow growing animals, and their natural predators, while they have some, they don't have a lot. It's only large sharks and killer whales. Uh, in terms of natural threats, it's mostly the degradation of coral reefs, which means a loss of habitats in their cleaning stations and stuff like that. Ocean pollution is a big one, especially microplastics, because when microplastics gets through to these filter feeder animals, it becomes toxic to their body. In terms of human interactions, minor threats include unregulated tourism, like divers touching them. Sometimes they can have they can create bacterial infection. Sometimes they just alter behavior. Boat accidents are rare, but they do occur. The major threat, however, again, lies in humans, particularly in commercial and subsistence unregulated fishing. While they are historically targeted in small numbers, they're initially not targeted. But with the decline of other large marine megafauna, like sharks, local fishermen have resorted to targeting rays. Their use mostly for their meat and their oil, but their most price value, I guess, lies in their gill plates, which are thought to be an all cure of some sort, similar to a shark fin, because they are believed to possess healing properties and being an aphrodisiac in Chinese medicine. It's propagated by a direct consumer marketing, which increases the demand. In regional habitats such as Mozambique, it's estimated around 1,000 are fish a year, while in more fish areas such as Indonesia, it's about 3,000 a year. Reef manta rays are easier to fish compared to their larger cousins due to their habitats, as they can be found uh, along 50 kilometers of coastline. Other fishing threats include bycatch, such as ghost nets and hooks. So, what's being done to conserve them? Well, one of the first effort being made is to raise public awareness. So they have been declared protected species in several countries, including Indonesia, Australia, Mozambique, Maldives, and Hawaii. In Australia, the giant oceanic manta ray is classified as protected, but not their smaller cousins. So we need to work on that. uh, in a case study of Indonesia in was it Nusa Tenggara in Lamakera, a ministerial decree have prohibited the capture, retention, and trade of manta rays through its exclusive economic zones. Community outreach includes the release of media articles, having a community reporting network, and essentially reporting illegal fishing. Enforcement actions include the use of water police and compliance management. The most important one, I believe, is a livelihood focus incentive. By cooperating with local businesses, they, they can provide employment and income, essentially creating an alternative livelihood so that these fishermen who have stopped fishing rays can actually still sustain themselves in their everyday life. And in that case study that I've mentioned before in Nusa Tenggara, where this framework has been implemented so well, in 2018, the manta ray mortality has decreased by 90%. So, what else is being done to conserve these animals? Well, they are a major tourist attraction, and a single manta ray is estimated to be worth $1 million in ecotourism over its lifetime, while the same manta ray could be worth as little as $150 if they're fished. They also aid in citizen science observation data. Ironically, ecotourism can be a bit damaging for manta rays. As I've mentioned before, it alters their behavior and is potentially harmful. So tourists do need to comply with rules and regulations, and the rules do need to be enforced heavily for sustainable nature tourism future. There's also conservation sites specifically done for nursery uh, geographical areas. This is being done, I believe, in Florida and some parts of Brazil. So what does this mean for their IUCN classification then? Well, when manta rays were first assessed in 2003, there was simply not enough information, making them data deficient. But it was estimated that their numbers are dwindling around 1950s, 1970s, when mass industrial fishing became more of the norm. Due to their fragmented population size, lack of research in global population, but having a dwindling population size, the IUCN has deemed reef manta rays as vulnerable, although more research is needed and more conservation actions are needed. So moving on to our green list assessment, why is it that we need to conserve these animals and what makes their population viable in terms of conservation? Well, first of all, they're very important ecologically as they regulate plankton abundance, they cycle nutrients, and they're also a known sentinel species. And to protect and conserve these populations for the future, we need to ensure that we protect individual regional populations. We need to ensure population dynamics are stable and genetically robust. And we need to manage local ecosystem surroundings accordingly to their state. So this graph was done based on the regions of Australia, Indonesia, Mozambique, Maldives, and the Philippines. Their population is very difficult to discern globally. I wanted to try it. I think I might have gone way over my head, but I've come up with the worst scenarios and the best scenarios. So their worst scenarios if is failure to implement management framework and enforce laws, like I've mentioned before, if nursery population crashes due to climate change and ecotourism become unsustainable, and you can see it from those crashed dotted lines. The best possible scenarios is local compliance, so when the public become aware of the issues, where alternative livelihoods become successful, ecotourism sustainable, and nursery population remains viable. While recovery potential might be undervalued due to lack of historical information, I might have overestimated its initial population, but I think conservation actions have been proven to be effective when implemented correctly, like in the case of East Nusa Tenggara. Due to its short conservation history, it's difficult to discern the future of the species. But I think for such a fragmented, highly fished species, a return to its initial state would already be a positive outlook in my book. So how do we work to make it a reality? Well, I think most importantly, we need to understand the varying socioeconomic status, community awareness, and willingness of locals to comply within regions. It's shown that huntings and landings were only reduced when marine patrols are out. Implementing a management framework best suited to the location and their ecological status, it's shown that national regulations and trade enforcement were shown to be ineffective, but when you enforce those laws, it does become effective. You need to adopt a multifaceted adaptive intervention methods. So understanding the community, their attitudes, and address the different drivers to compliance. You need to promote conservative attitudes, making it a behavioral norm, and motivate the people through incentives. Marine sanctuaries only work if the decreed laws are enforced, and community outreach can only be achieved through mutual understanding. Lastly, other conservation methods are being used, like more novel ones, such as acoustic telemetry and satellite telemetry, excuse me, so that we know essentially the future of these animals and how they're going to be facing all their these impacts and threats and how they're going to live through them. That's it. Thank you.